So if you remember on the last video, I told you that if you had the square root of 16, you should just tell me 4. But remember at the beginning of that lesson, I was talking about how negative 4 should also be in there because the square root of 16, negative 4 times negative 4 is still 16. Well, here's the difference. Here's what I want you to do. If you have a straight up, the problem gives you exactly that, then tell me that. Okay, just tell me that it's 4. But if you're solving an equation, our whole point of solving an equation is to figure out what could x possibly be. Any solution could it possibly be. So if there could be more than one answer, we should find all the answers. So if I have x squared equals 16, in order to get rid of the squared, I'm going to undo the squared, which is square rooting. So I'm going to square root both sides. And so now my square root and my squared cancel, I get just an x. And the square root of 16 is positive 4 and negative 4. So I'm actually going to say plus or minus 4. So here's the rule. If, in a problem, you are the one bringing in the square root, then you should do the plus or minus. Notice in orange, the square root's in orange because I brought it in. I said in order to solve this, I'm going to apply a square root. I came up with the square root idea. So that means I'm going to put a plus or minus 4. But if the problem already gives you the square root like above, if it already gives you the square root, you didn't bring in the square root, it was already there, then you should just say the 4. So if you're solving an equation, use the plus or minus. So here we've got two different types of problems to solve. And I want to show you both of them. Here's the big idea. Let's even write this down. I think I might write it in red just so that you remember it. Big idea. This is a good thing to write in your notes. Big idea. Ready? Get the thing being squared by itself. Then square root. That's what I'm going to do. That's what I'm going to focus on. I'm getting what's being squared, whether it's just an x or it's a whole bubble. I'm getting what's being squared by itself, and then I'm going to square root. So let's go with this first one here, where the thing being squared is just x squared. So I'm going to get x squared by itself. Just like before, we subtract 1 from both sides, so we get 2x squared equals 16. I have to divide by 2. X squared equals 8. All right, now I've got to get rid of the squared, so I'm going to bring in the square root. Remember what happens when you bring in the square root. You got to use a plus or minus. But first on the left, I've got a square root and a squared that cancel, so I get x equals. And then I've got plus or minus. Now, the square root of 8. 8's not a perfect square. But I can split up the 8 into 4 and 2. And remember that last lesson, if I square root that, the square root of 4 is 2. And the square root of 2 is still the square root of 2 because I can't square root it. And so there's my full answer. X equals plus or minus 2 square roots of 2. Now let's look at the next problem. The next problem, it's not just x to the second power, it's a whole bubble to the second power. So once again, I'm going to get the bubble by itself. I'm going to get the thing being squared by itself. So I get rid of the 3, it's being multiplied, so I'll divide. And I still have x minus 2 squared equals 7. Now I got to get rid of the squared, so I'm going to square root the whole thing. The square root and the squared cancel, so I'm just left with x minus 2 equals. Now remember, we brought in the square roots, so it's going to be plus or minus square root of 7. Now guys, square root of 7, 7's prime, I can't simplify it, so we're going to leave it as a square root of 7. Now I still got to get x by itself. It's still my goal to get x by itself, so I need to get rid of the 2. I'm going to add 2. So then x equals. Now here's the tricky part. It's not really that tricky, but for some reason people think it is. See that 2? That 2, not inside a square root. That 7, inside a square root. So what we're going to do is we're going to write it as 2 plus or minus the square root of 7. And we're going to leave it like that, 2 plus or minus the square root of 7, because that's exactly what this says. See? It says 2 plus or minus the square root of 7. So we'll just leave it like that. And that, my friends, is the answer. So let's look at a couple more examples here. All right. Oh, let's see what color, blue. All right. Again, I'm trying to get this thing being squared by itself. This time it's going to be an x squared. So get rid of the 3. I subtract 3 on both sides. So I have negative 5x squared equals negative 12. Divide both sides by negative 5. So x squared equals 12 over 5. I square root both sides so that my square root and my squared cancel, and I get x equals plus or minus. Oh boy. See on top, that 12 is 4 times 3. The square root of 4 is 2. I'm left with the square root of 3. And I still have a square root of 5 on bottom. And so now I need to get rid of the square root of 5, so I multiply by square root of 5, top and bottom. Oh, this is getting messy, isn't it? Woohoo! So, let's see here. On top, let's see, plus or minus 2. See, here's I got the square root of 5 and the square root of 3. I can put those back together. It's the square root of 15. 3 times 5 is 15. On bottom, square root of 5 times square root of 5 is 5. Again, I want to point out something, guys. These don't cancel. See the square root of 15? There's not really a 5 in it because it's inside the square root. So technically, it's not a 15. It's disguised as a 15, but it's inside the square root, so it's technically not a 15. All right, so this is my answer. I'm actually done with this one. Let's go up to the next one. Again, this is a squared with a bubble. And so I want to get rid of the 1/3. I'm going to multiply by the reciprocal, 3 over 1. 3 over 1 over here. So those all cancel out. I get the bubble to the second equals, 17 times 3. 3 times 7 is 1. Carry through 51. All right, then I square root both sides. Square root and the square cancel. I get x plus 5 on the left. On the right, I get a plus or minus. And see, now 51, there's no perfect square in there, so it's going to stay the square root of 51. And then I get rid of the 5. I subtract 5 from both sides, so x equals -5 plus or minus the square root of 51. You know what, you guys? The biggest mistake you're going to make is you're going to forget the plus or minus. So prove me wrong. Don't forget the plus or minus. Oh, here's some fun. All right, here we go. Here's what's going on. This bad boy right here, it's called your position function. You'll actually see it a lot in physics. So if you're taking physics at all, you've probably seen this already. We're actually going to use it a bit here because it applies itself so well to what we're learning right now. And so here's how this is set up. You're always going to have this h right here. Now h is your height in feet of whatever you're talking about. So if you're talking about something that's going to land on the ground, h would be 0. If you're talking about something and you want to know when does it get to 200 feet in the air, then h would be 200. Okay, then we have t. T is our time in seconds. That's all there is to say about that. And then h naught, that h subscript 0. That's our initial height. Where does the object start? Is it a rocket that's being shot in the air and so it starts at 0? Or is it something falling off a building and so it starts at 400 on the top of a big building? So it all depends on what your initial height is. All right, so let's look at this. Oh, by the way, it's always in feet here. You might, if you are in physics, you might think that you would recognize if this said -9.8. If this number instead of -16 was 9.8, then you're looking at talking about it in meters. It's the same equation as just in meters. So the 16 comes from being in feet. So here's our problem. The tallest building in the United States is in Chicago, Illinois. It is 1450 feet tall. That's going to be an important thing for us later. How long will it take a penny to drop from the top of this building? The top of this building. How long will it take a penny to drop? So we're trying to answer t. T is going to stay there. It's going to be our variable. So what we need to do is we need to plug in information we know. What was h? What is our ending height? Remember h? This is the ending height. So what is our ending height? We want this penny to drop from the top of the building. I'm assuming that means to the ground. So h would be 0 equals -16. Remember, we're trying to answer t, so t is going to stay in there. Plus, remember our initial height. It's from the top of the building, which means the top of the building is 1450. And so now, it's our job to solve this. I need to get the thing being squared by itself. So, let's move the 1450 over, so subtract 1450. Alright, so we have -1450 equals -16t squared. And then I'll divide by -16 equals t squared. So let's see, 1450 divided by 16. Oh, it's not perfect, you guys. And do you know what? Life is never really perfect. So we get 90.625, and we're going to use this and we're going to leave it. And what's going to happen is when you're using a word problem and you don't get perfect numbers like we have been, and you do this problem, you're actually going to use a calculator and figure out as a decimal. So t squared, I'm going to square root both sides. Okay, so then t equals, remember it's going to be plus or minus. And the reason we actually find this out as a decimal, even though it's rounding, like I told you before that we don't want to do that because it'd be rounding, does it really make sense if our answer to someone was the square root of 90.625? They'd have no idea how many seconds that means. I have no idea how many seconds that means. So you actually want to figure this out as a decimal. And so when I plug it in the calculator, I get plus or minus 9.5, basically rounded. All right, now let's talk about the plus or minus thing. Remember, t is time in seconds, so a positive 9.5 seconds and a negative 9.5 seconds. We can't go back in time yet, so we actually have to ignore the negative part. And so our answer is going to be 9.5 seconds. And we should answer it with our units to make sense of this. And then the question is, how fast would the penny be traveling when it hits the ground if the speed is given by s equals 32t, where t is the number of seconds since the penny is dropped? We just found out that it's 9.5 seconds. So that means we're going to take this 9.5 and plug it in for t into this equation they gave us. So s equals 32 times 9.5. And 32 times 9.5 is 304. So 304, what is it saying? How fast would it be? I would say that's in feet per second. So it's traveling at 304 feet per second. All right, let's continue on with the next problem. So this one says, how long will it take an object dropped from 550-foot tall tower to land on the roof of a 233-foot tall building? So let me start us off by reminding you the equation. It's h equals negative 16t squared plus h naught. All right, so a lot of times confusion comes in. Which one is our starting height and which one's our ending height? Think of 0 as always being the start, the very beginning of something. So h is our starting. So it's being dropped from 550, so that's our starting height. Okay? And then h is our ending height, and they're saying it's not landing on the ground, it's landing on the roof of a building that's 233 feet tall. So there's 233. So my equation should now say 233 equals negative 16 t squared plus 550. And so I go ahead and solve. I'm going to subtract 550. So we have 233 minus 550 gives me negative 317 equals negative 16 t squared. I divide everything by negative 16. So let's see, 317 divided by 16 gives me 19.8. But that's what t squared equals. That is not what t equals. So then I'm going to square root both sides. Remember, when you square root both sides, you need a plus or minus. So I'm going to look for the square root of 19.8. And that gives me 4.45. Again, you can't go back in time. So this negative I can get rid of, in fact. And then I should actually answer it. So it's going to take 4.45 seconds. All right, those are your word problems. Good luck.